Alright, so here we're going to prove that any two diagonals of a regular pentagon must be congruent. And I think this proof doesn't lend itself real well to the two-column format. So I'm going to just kind of like explain this to you and see if you can kind of write it out in your own words. Alright? So I've got two copies of the same pentagon here. Regular pentagon, which means all the side lengths are the same and all of the angle measures are the same. And this is probably the worst looking pentagon I've ever drawn. Okay, so all the angles are the same, all the side lengths are the same. Okay, so I have two diagonals drawn here. You'll notice that the two diagonals, along with the two sides on either side of them, and by the way, you can't draw a diagonal of a pentagon so that it doesn't make one of these little triangles. Right? No matter how you draw it, it's going to make a little triangle up here in the corner. Well, the two sides here in the triangle are going to be congruent, because they're two sides of the pentagon. So no matter how I draw the diagonal, the two outer sides of that triangle are always going to be congruent to each other and congruent to the two sides of any triangle that I make by closing it off with a diagonal. Also, the angle in between them will also be the same no matter where I draw the diagonal. It's always going to be the same because all the angles are the same. Specifically, they actually have a specific measure we can calculate it, but I think it's, 5. About that one. 1, 8, whatever. But regardless. Anyways, so no matter where I draw the diagonal, the angle at the top of it is always going to be an isosceles triangle. It's always going to be the same two side lengths on the isosceles triangle. And it's always going to be the same angle measure in between those two congruent sides, because all the angles are the same and all the side lengths are the same. And therefore, any diagonal I draw is going to create the same little isosceles triangle, just in a different position. And if it creates the same little isosceles triangle congruent, then the diagonals themselves must also be congruent, because corresponding parts of congruent triangles are congruent.